be talking about today is how to make a dilution. But before we work on dilutions, let's first talk about what we've already discussed, which is how to make a solution. Because you need a solution first in order to make a dilution. So, if you wanted to make a solution, then you could take something like Country Time lemonade and you could put that sugar inside of some type of thermos, right? And then what do you do to it? It's not a solution yet until you do what? You add water. Perfect. And so the big question always is when you're making this is, how much am I supposed to add, right? Because you could add a little bit and then you can add a lot. And so you look at the back and you try to figure out how much it is that you need to add. Well, in chemistry, what we do is we do a calculation and we figure out how many grams of a certain substance that is that we need, and you put that into typically a volumetric flask, and then what do you do to it? Add water. Perfect. And then you're going to add water to it, and that's your solution. Then you stir it, and that's going to be your solution. So what we were talking about is different types of solutions. We were talking about either you could have a saturated solution or a supersaturated or unsaturated solution. What does it mean to be saturated? Do you remember what it means to be saturated? It's basically what? It's full. I'm hearing full. It's dissolved all of the solid that it can. So what happens is you start to see at the bottom, you start to see some powder. Okay, you see solid that's undissolved, and then you know that you've reached the point of saturation. Okay. Now, supersaturated is a little bit different. So I mentioned to you that if it's supersaturated, it's not just that it has too much. It's a special way of making a supersaturated solution. What you do is you increase the temperature, and then you're going to add your solute to it, and you get more solute to go into it when it's at a higher temperature. And then you cool it down. And when you cool it down, crystals start to form. So I'm going to show you this quick little demonstration of sodium acetate. And so on this demonstration, what you're going to see is this person heated up this sodium acetate, and it was hot. I've actually made the solution too, so I can show that to you, but it's nicer to see it's enlarged here. And then on here, you just take a couple of crystals, and you're going to drop these crystals, they're seeds basically, that are going to be added right into this solution. So after you make it, it's hot. And then you take it, you cool it down a little bit, and watch what happens as soon as he adds one tiny little seed. What's happening? Yep, you're seeing it solidify. And so that's what I have right here also. So I heated it up, it all went into solution, and basically it was only a few milliliters of water for, I think it was something like 35 grams. Which is a lot for only a few milliliters of water. And so then you can basically flip it around and you just added the one seed crystal. And so that's your supersaturated solution. When you go to make the lollipops or the rock candy works the same way. You actually want that seed crystal. And so that's why when you make the rock candy, you want to roll your lollipop stick in sugar, and then you're going to put it in, because that's going to be your seed crystal that's going to start the formation of those crystals. With lollipops, you actually don't want that, okay? The lollipops, you don't want it to be that way. All right, so let's come back to the notes here. So when we made a solution, there was a statement that we made. And what we said was, you're going to weigh a certain amount, you're going to put it into a volumetric flask, and then you're going to add water until you get a total volume, a certain total volume. And so what we said was, you find the volume in the problem. In this case, it was 2 liters, and that's what you want your total to be. So now, what happens is we come to a point where we've already made a solution. So imagine that we made a solution, and let's say that we had a bunch of lemonade. And I love lemonade super concentrated, okay? So my lemonade that I make, if I'm making it at home, and you'll have some today, when I make the lemonade, it is pretty much saturated. There's sugar particles floating around in there, okay? So my husband doesn't like it that way, but my boys like it the same way I do. So he doesn't make his own container of it. What does he do if he doesn't like it that way and he actually likes it more dilute? What does he do? Take a guess. Adds water. But he's not going to add water to all of ours because there are 4 of us and there's only 1 of him. So what is he going to do? Pour some into a cup and then do what to it? Add water. Okay? And that's going to be a diluted solution for him. So what I first want you to understand is this. if I had a particular solution, and let's say I told you that I had a 0.5 molar solution. Remember what that big M stands for? So it's, the first part's easy. What is it in molarity? What's the first part? Moles, and the end of it is divided by liters. Perfect. Okay, and I said you could flip the letters around and it kind of looks like liter. So let's say that I had a 0.5 molar solution. And I took some of this, and I had, let's say that I had a liter of it, okay? And I poured into different containers. And let's say that in each container I poured 25 mils in one, and 30 in the other, and 75 in the other. What's the concentration of every single one of those? Still what? The same. Why is it the same? Because you haven't done what? You haven't diluted it. You haven't added water to it. I want to make sure you understand that first, okay? Because I will tell you that in one of my AP classes, I asked that question, and people pulled out calculators. And I said, the question was basically, you pour 50 milliliters into a beaker of a solution that's 0.5 molar. What is the new concentration? And they were trying to calculate it. There is no new concentration, okay? So, as long as you're pouring some of this out, it doesn't matter. Your moles per liter, the ratio of it is actually the same. So, what could you do in order to change the concentration? There are three things you can do to change the concentration. One I heard was do what? What we were just talking about. Add water. That's one way to change the concentration. What else could you do? You can add more of the solute. Perfect. You can add more sugar to it. That would change the concentration. And what else? What's the third thing that you could do? You could heat it, and what happens? You could evaporate the water, and what that does is that still increases the concentration, because what you do is, by getting rid of the water, the sugar will stay behind, and then you have more sugar per unit volume. So your ratio would also change. So you're looking at the ratio, and when you're talking about the concentration. So the cool thing about this making a dilution, a scientist came up with an equation again. Again, remember that an equation is just, they found a pattern. It was like, if I do this, and I multiply by this, and I divide by this, I'm going to get the answer. And so that's what they came up with, was an equation. And this equation looks very similar to what? What that we've just done. Yep, P1V1 equals P2V2. It looks a lot like that, okay? And what we said when we were doing the combined gas law is we said it was basically like using, in math, it starts with an R, we call it a ratio. Perfect, it's using a ratio. We're going to do the same thing with this. So let's first talk about molarity is not really a unit, okay? So it's an abbreviation of 2 units. What did we say molarity is again? Moles over liters. And then volume, you could use milliliters here just like you could with P1V1, as long as you know that you're using the same unit. But technically, it would be in liters. So that's my moles over liters there. And I set it equal to, again, I've got moles over liters times liters. What happens mathematically? The liters cancel out, and you're left with moles equal moles. And it's correct because the idea is, if I had lemonade in here, and I poured some into a different cup, those moles actually spread themselves out equally. So I would assume that the amount of moles would be the same. Well, what if you add water to it? Have you changed the amount of sugar that you had in there? If you add water to it? No, the sugar's still the same, which again, if your grams or the moles are still the same, then we've come up with the ratio to say, well, all I'm doing is adding water to it, so really the moles should stay constant. And that's basically what this equation does for us. So let's try out this equation and see where it takes us. It says, how many mils of 2 molar HCl must be added to appropriate amounts to make 500 mils of a 0.5? We know we want to make this stuff. Okay, we're going to label everything again, all right? So this here is what we're looking for. Milliliters is a unit of what?
Volume.
Volume, perfect. So there's our V. And then this we said is an M, right? Now we're going to come over and see, now what is this? That's another V. Okay, but the question is, one of them is V1 and one of them is V2. It doesn't matter mathematically which way you do this, but technically, if we wanted to do this correctly, which one is original? Which one, or maybe I should ask you, is this the final amount or is that the original amount that we already have? That's a final. We don't have this yet. We're trying to make this. So we're going to call it V2, and if we call that V2, then we would also call this M2. But really, when you're going to do your calculation, it doesn't matter. So then we're going to call this V1 and M1, as long as you put the correct ones together, okay? It's not going to matter algebraically. So let's write our equation. It's M1V1 equals M2V2. And leave a little bit of space on the right side because we're going to write a statement out. All right. So what's our M1? We know that. What's the first initial one? 2.00 molar. And our original volume is what we're looking for. We're trying to figure out, you don't want to be wasteful. So we're trying to figure out how much of this stuff are we going to take out. Because again, like I told you, if my husband diluted all of this, I'd be really upset with him. So it would be like, you take out how much you want and do your own little dilution. Don't mess with our entire solution, okay? So same thing. So in this case then, M2 would be what? What's your final molarity that you're trying to get? 0.5. Yep, 0.5 molar, 0.500 molar is what we're trying to get. And our final volume we want is 500 milliliters. Okay, if you want V1 alone, how do you get V1 alone, algebraically? Divide by 2. But if you do it on this side, you have to do it on the other side, remember? Okay, so the multiplication property. And so in this case, we're going to multiply. I always say start opposite your unknown and multiply, and then divide. Please tell me what you get for V1. 125? Awesome. 125 milliliters is what we get. All right, that's really, really nice. But that's only one major part of this problem because I told you how I was in lab and at the university level, and they had a solution that we had to make. Well, then there was another part to the lab where, let's say, I don't remember what the exact molarity was, let's say it was a 0.1 molar solution. In the second part to the lab, it said, now using 0.03 molar of the solution. So what I did was, I went over back to the original solid, and the TA caught me over there and was like, you can't make 0.03. And I was like, well, I made 0.1 molar using that, so I know how to do a solution calculation. He said, no. You're not going to use the solid. You need to use a solution you already made. So it's no longer called a solution making. Now it's called a dilution. So I need to dilute it. And so the calculation was done, and great. I could come up with the answer. But now what? Now, what do you do with the fact that you just calculated 125? How are you supposed to make this dilution? Well, the statement looks very, very similar to solution making, okay? So, but we're not weighing anything. So when we come back and we take a look at what we said here, we said weigh and place the 357 grams into a volumetric flask, and then we added water until the total volume was 2 liters. It'll be very similar, but we're not weighing grams. What are we doing now?
Measuring volume.
Measuring volume. Perfect. We're going to pour how much? Yep, 125 mils. Perfect. Now, what is the 125 mils of? And I'm going to give you a huge hint, big tip. V1 goes with M1. So what is this 125 mils of?
HCl.
Perfect. Of the HCl, but which one? Because they're both HCl. The first one, the 2.00 molar. Awesome. Of the 2 molar HCl into what? What do you think we're going to pour it into? Same instrument. What kind of flask? Volumetric flask. Perfect. Into a volumetric flask. And now we've got the second part to this. So period. Second part. Now we've poured it in, but just like we said, if you just pour that into a different cup, the lemonade, you haven't changed the concentration. What do you need to do now? Add water. Awesome. You're going to add water. Now here's the hardest part. But it should be easy because it makes sense. You want to make sure it makes sense. You're going to add water until the total volume is what? Awesome. Nice. Until the total volume is what you're trying to get, which is 500 mils. Okay? So it's really cool because what some people want to do when they see something like this is they're like, okay, well, I'm going to work out a ratio for it. Well, that's what this is. That's what the equation is. It is a ratio. And what that number is going to tell you is how many mils of the original you need to pour out and how much water you need to add. It doesn't tell you how much water you need to add, but you can subtract to figure it out if you know your total, okay? But this is the proper way of doing this type of dilution in lab. Okay, so let's try one more just to make sure we've got this. So this problem is very similar. It says I need 15 mils of this. So do you have it now? Do you have it today? No. So what would you call this? 15 mils. V2. And then this is also, you don't have it yet, so this we're going to call M2, which makes this one M1. Perfect. And then what are we looking for? Well, we're looking for how to make it. So we're actually looking for V1 again. There are problems where you'll be looking for what is the concentration if you've made this dilution, if you've changed it by this much, and so you could be solving for different things. Okay, so we know our M1 right there is 0.300 molar, and our V1 is what we're looking for. We want to know how much we're taking out. Our M2 is the final concentration, which is the 0.1 molar, and the V2 is the 15.0 milliliters. So again, how do we solve for V1?
Divide.
Yep, divide by 0.3 on both sides. So please tell me what you get for V1. 5. Awesome. 5.00 using 3 sig figs milliliters. Again, we're in great shape, but now how do we make it? So I'll tell you that I had mentioned about the AP class not knowing what to do with that problem. Same thing happened with this. They were able to do the calculation. It was beautiful. Calculations they're really good at. And then I said, okay, go make the dilution. And I said, we did this in honors chem, so I'm not going to tell you how to do it. You need to see if you can figure this out. And I put people in groups, and they were talking about it, trying to figure it out. One group's statement, I said, I need to see your statement so you're not being wasteful. I need to see your statement first. And one group's statement was, it was something to the effect of, pour 15 milliliters of hydrochloric acid into a volumetric flask and add water until your total volume is 5. Could you add 15 mils and then add more water until you get 5? Does that make any sense? So I was like, wait a minute, will you read what you said again? Because does that make sense? And then they kind of all started laughing. And they were like, no, it doesn't make any sense. You can't add water until you get 5. You have to take away stuff to get 5. So please make sure that you do this correctly. So first part of the statement is what? Pour 5 milliliters of what? Good. Of the 0.3 molar CuOH2 into what? Good. Perfect. Into a volumetric flask. And then the second part of this, step 2. We've poured it, but we haven't changed the concentration yet. Now what? Add water. Perfect. Until the total volume is what?
15.
Nice. Is 15.0 milliliters. Okay? And you do want the total volume to be that. Sometimes when you dilute things, a lot of times, if you're adding like alcohol to water, the volume actually decreases. So you do want to make sure your total solution is equal to that final volume. Okay, and that's basically it for doing dilution.